Good morning, guys. This is the beginning of a new chapter, Chapter 5 in Statics, Equilibrium of Rigid Body. It is a very important short chapter, and this chapter will be used by civil and mechanical courses later on. So, guys, this chapter is about the equilibrium of a rigid body. Before starting by the equilibrium of a body, let's define a rigid body. What is a rigid body? A rigid body is basically a body subjected to certain force, but its deformation is neglected. So basically, a rigid body is the body where the deformation could be neglected. And this is, guys, our case here. Now, what is the equilibrium of rigid body? Equilibrium, guys, means that the sum of forces applied on this body should be equal to 0, and the sum of moments applied on this body should be equal to 0. This means, guys, that this body could be either in translation with a constant velocity so that the acceleration in translation is equal to 0, or it is at rest so that the velocity is equal to 0, as well as its rotational velocity is constant so that its rotational acceleration is equal to 0, as well as it is at rest, which means it is not doing a rotation, which means that its rotational velocity is 0. So these are the cases where the body could be called in equilibrium. So guys, it is not enough to say the sum of F is equal to 0. You should also say that the sum of moments is equal to 0, because in fact I can have a rotation. Now I know, guys, that the sum of forces is equal to F resultant, and this means, guys, that F resultant should be equal to 0 in equilibrium, and M resultant should be equal to 0 in equilibrium. And remember, guys, as we state in the previous chapter, that M resultant is equal to the resultant moment of all the forces plus any external moment. Okay. Now, what is important in this chapter is the introduction of supports. So supports, guys, are used to support a beam or a body. And there is a lot of types for support. So what is a support basically? This table here is a support, because in fact, if I put this mug on this table here, this mug, guys, will not fall down. Which means, guys, that this table is doing a force on this mug to prevent it to fall down. This means, guys, that this table is doing what is called reaction. So basically, guys, this table is doing a reaction on this mug in order to prevent it from the fall. However, guys, this table is not preventing the translational motion of this mug in horizontal direction, which means, guys, that this table is not doing a horizontal reaction. It is only doing a vertical force or a vertical reaction. And from here, guys, comes the two main rules. The first main rule states that if a support prevents the translation of a body in a given direction, then a force is developed on the body in that direction. And this is what is called reaction. In French, réaction normale. So this is what is called reaction. It is the reaction of this body to prevent a translational motion of another body. Which means, guys, that this table is doing a force on this body, and this force basically is an external force on this body here, on the mug. Now, same goes for rotation. If rotation is prevented, does that mean that I have a force that is preventing a rotation? Basically, no. I have a couple moment that is preventing this rotation to be exerted on this body. So basically, guys, if I put a support that is preventing this body to rotate In this case, guys, I'm doing a couple moment as a reaction. And this couple moment, guys, will be in the opposite direction of the resultant moment of all the forces on the spectrum. So let's now go over some types of supports. I will start first by what is called roller. Roller, guys, is basically a support that is doing a vertical reaction. However, it is not doing a horizontal reaction, like this case. So let's take, guys, two pens. These two pens are called rollers. And assume that this is my beam here. Now you can see, guys, that this beam, or that these two supports or these two rollers can hold this beam, which means if they can hold this beam, they can prevent the fall of this beam. In this case, since they prevent the fall of this beam, then this means, guys, that these two rollers are doing a vertical reaction preventing the fall of this beam. However, guys, this beam can do a translation. And this means, guys, that these two rollers cannot prevent the beam from doing this horizontal translation. And this means, guys, that I do not have a horizontal reaction caused by these two rollers on the beam. Now the second case is the pin. The pin, guys, is basically like this case here. So I have a wooden bar, and this wooden bar is pinned at a point, which is this one. Imagine, guys, that I'm hanging this wooden bar on the wall, so that this beam is attached to the wall. This means, guys, that this beam here, so if this beam is attached on the wall, assume that my hand is this wall here, then this means, guys, that this beam cannot do a vertical translation, neither a horizontal translation at the point of the pin. So, guys, this pin prevents the horizontal and the vertical translation. And this is unlike the roller that is only preventing the vertical direction. In this case, guys, I have two reactions, vertical reaction and horizontal reaction. However, this pin cannot prevent the rotation of this beam on this point. So, guys, you can see that I have a rotation on this point. So this rotation here could not be prevented, which means I don't have a reaction moment that is preventing this rotation. In other words, guys, if I put a force here on this wooden beam, this wooden beam will do a rotation. Which means, guys, that this pin here cannot prevent the rotation. It can only prevent the translational motion. So that's why, guys, for a pin, I have two reactions. One is vertical and the other one is horizontal. Now, what if I need a support that can also prevent the rotational motion in addition to the translational motions? This is the case of what is called cantilever. So, guys, basically, in order to prevent the rotation, I should have a fixed support. And this is a fixed support here. So, guys, this is my fixed support here. In this case, guys, this fixed support here will prevent, first, any vertical translation at this point, any horizontal translation at this point, and any rotation at this point. So any rotation is also prevented because in fact this beam is fixed at this point, and this is what is called fixed support or cantilever. So in the case of fixed support, guys, in the case of fixed support, at this point I have a support that is also preventing the rotation. Okay? And in this case I have three reactions. The first reaction is basically the vertical reaction, the second is the horizontal reaction, and the third one is a couple moment reaction. So as you can see here, at this point I should put F1 or Fy, Fx, and a moment. And basically to prevent the rotation at this point, I should have the sum of moment at this point should be equal to 0. In other words, guys, this moment here will be the opposite of the M resultant of all the forces or plus any external moment on this beam. So if I can find M resultant, which is equal to the moment of all the forces on this beam plus any external moment, this M here, which is the M caused by this fixed support, will be equal to minus the M resultant. Okay. Now guys, you should know that I can also have different other types of connections or of supports. Some of them are very familiar, like the cable or the rope. I know, guys, that if I have a cable or a rope that is holding anybody, the reaction or the force developed in this cable or in this rope will be along this rope. So if I have a rope, the tension will be along this rope, like in this case. So this is my cable here, then this will be the force F. And this is also could be applied for the weightless link, because in fact a weightless link is also a rope, because the first assumption that we did for the rope is basically that its weight is neglected. Now what I want you guys to know, that if this roller here is oblique, which means if I have this case, for example this book, and this is my roller, okay, so if this is my roller, and if I have a body that is doing any angle with this roller, basically the reaction is always perpendicular to this roller, and it is not perpendicular to this body. So it is always, guys, perpendicular to this roller and not perpendicular to this body. So the first case was the conventional case where the roller reaction is vertical. Now, this case here, guys, this case in the slide here has a roller that is oblique, which means, guys, that the reaction should be perpendicular to the support of this roller and not to the member or to the beam. Okay, and same goes for the rocker. So the rocker is the same as the roller, but instead of having wheels for the roller, the rocker is by itself a wheel that is doing a rotation. Okay, so I will stop now. This will be the introduction of this chapter. Later on, we will talk about the steps to solve the problems in this chapter. Thank you.